Some mornings, your coffee tastes like heaven, rich, smooth, and perfectly balanced. Other mornings, it tastes flat, bitter, or even a little sour. You follow the same routine, use the same beans, and the same method. So why does it change? The answer isn't magic. It's chemistry, environment, and even your own body all playing a role. Today we're going to unravel the science behind why your morning cup can feel completely different, even if nothing seems to have changed. Coffee is one of those simple pleasures in life, yet it's surprisingly complex. Millions of people start their day with a cup, and for many, it's more than just caffeine, it's a ritual, a comfort, a little science experiment in a mug. But have you ever noticed that even when you stick to the same brand, the same grind, and the same brewing method, your coffee can taste completely different from day to day? Some days, it's sweet and nutty. Other days, it's bitter or sour. If you're like most coffee drinkers, you've probably blamed your equipment, your mood, or even the weather. But the truth is that the variation is a natural consequence of chemistry. Every component of coffee, from the bean itself to the water, the grind, and even your own taste buds, interacts in a delicate balance that can shift daily. The flavor compounds in coffee are numerous and fragile. Coffee beans contain hundreds of aromatic compounds, acids, and oils that contribute to their taste. These compounds react differently depending on factors like humidity, temperature, roast level, and storage. Even tiny fluctuations can cause noticeable changes in the final cup. Think of coffee like a symphony orchestra. Each chemical is an instrument, and if one violin plays slightly off-key, the music sounds different. But the variations don't make the coffee worse. They make it unique and dynamic. Coffee is not a static beverage. It's alive in a chemical sense, responding to environment, preparation, and even your perception. Understanding these variations can help you appreciate your cup more. When you take a sip and notice subtle differences, you're witnessing chemistry in action. The sugars, acids, and oils are interacting with water at specific temperatures, extracting different flavor profiles and interacting with your taste receptors in unique ways. Your coffee isn't failing, it's expressing its complexity. This perspective shifts the experience from frustration to curiosity. By paying attention to these variables, you can start experimenting, adjusting, and understanding your personal taste preferences in a much deeper way. So, if you've ever wondered why coffee doesn't taste the same every morning, the answer lies in a combination of bean chemistry, environmental factors, roasting, brewing techniques, and even your own physiology. It's not a defect. It's nature and science collaborating to give you a dynamic, living beverage. One of the biggest factors affecting daily coffee flavor is where the beans come from. Coffee is an agricultural product, and like all crops, it responds to its environment. Factors such as soil composition, rainfall, altitude, and temperature all influence the chemical profile of the beans. This is why beans from Ethiopia, Colombia, or Brazil each have distinct flavor characteristics, even if they are the same species. Soil minerals influence acidity and sweetness, while altitude affects bean density, which in turn affects roasting behavior. Even within a single farm, seasonal variations can produce beans with different chemical compositions. Rainfall patterns, sunlight exposure, and temperature fluctuations affect the balance of sugars, acids, and oils within the bean. A harvest after a particularly wet season might produce beans that taste fruitier, with brighter acidity and more pronounced aromatics. In contrast, a drier season could yield beans with nuttier, more bitter flavors. These changes are subtle, but when roasted and brewed, they become noticeable in your cup. In essence, your coffee tastes different because the beans themselves are slightly different each day. This is part of the magic of coffee. Unlike manufactured products with consistent chemical formulas, beans are living plant material. Each batch is a snapshot of a specific environment at a specific time. Even beans from the same lot can vary slightly in moisture content and chemical makeup, which influences how flavors are extracted during brewing. This variability is what gives coffee its depth and character. It's also why specialty coffee roasters often mark beans with harvest dates and regions. They want you to experience the nuances that make each batch unique. Understanding the origin of your beans also changes the way you perceive flavor. When you notice a coffee tasting brighter or sweeter than usual, it's not an error. It's a reflection of the growing conditions, weather, and care that went into that crop. Your daily cup is a chemical snapshot of a distant farm, affected by natural variables you'll never see but can taste in your mug. This connection between environment and flavor highlights that coffee is a living product, not a static commodity. Appreciating this can make the differences in taste less frustrating and more fascinating, turning each cup into an opportunity to explore science, geography, and agriculture all at once. The species and genetics of coffee beans also play a huge role in why your coffee tastes different day to day. The two main commercial species are Arabica and Robusta, but within those species, there are countless varietals with their own subtle flavor profiles. Arabica beans are often sweeter, with higher acidity and complex flavors, while Robusta beans are bolder, more bitter, and higher in caffeine. Beyond species, even small genetic differences between plants on the same farm can produce noticeable flavor differences. You can think of this like siblings in a family. Two Arabica plants grown side by side may share many characteristics, but one might produce beans with brighter citrus notes, while the other leans toward chocolate or nutty flavors. These differences are determined by genetics interacting with microenvironments on the farm. Soil composition, water availability, and sun exposure can amplify or mute genetic tendencies. Because each harvest is a combination of countless plants, the overall flavor profile can shift subtly over time, even if you use the same beans every day. Genetics also influences the chemical makeup of the beans, levels of natural sugars, acids, caffeine, and aromatic compounds. These molecules interact differently during roasting and extraction. A minor difference in sugar content can affect caramelization during roasting, resulting in a sweeter or more bitter cup. Variations in acids can make the coffee taste brighter or tangier. These natural fluctuations are why even a perfectly measured cup from the same beans can taste slightly different depending on the batch or even the day. Understanding the role of genetics in coffee reminds us that no two cups are ever truly identical. The flavors you experience are a combination of plant biology, environmental factors, and the chemistry of roasting and brewing. Embracing this variability can make coffee drinking more exciting and less frustrating. Instead of searching for a perfect, repeatable taste, you can appreciate each cup as a small window into the plant's biology and the complex interplay of natural chemistry that gives coffee its character. Roasting is where coffee truly transforms from a green raw bean into the aromatic, flavorful coffee we know and love. It's a fascinating chemical process, and it's one of the main reasons your coffee can taste different every day, even if you're using the same beans. During roasting, the heat triggers several chemical reactions simultaneously, changing the bean's structure and flavor profile in ways that are both subtle and profound. One of the key reactions is the Maillard reaction, which occurs when amino acids interact with sugars. This reaction is the same one responsible for the golden crust on bread, the caramelization of onions, and the savory notes in seared meat. In coffee, it produces hundreds of new aromatic compounds, contributing to nutty, chocolatey, and caramel-like flavors. Caramelization of the beans' natural sugars also occurs at high temperatures, creating sweetness and complexity. Depending on how long the beans roast and at what temperature, different flavor notes will dominate. A shorter, lighter roast might highlight floral or fruity notes, whereas a darker roast can bring out deeper chocolate, caramel, or smoky flavors. Even minor variations in roasting temperature, time, or airflow can subtly shift these reactions, changing the resulting taste. This means that two batches from the same coffee farm, roasted a day apart or by slightly different machines, can taste noticeably different. The beans also release oils during roasting, which contribute to mouthfeel and aroma. These oils are delicate and can degrade if the beans are stored for too long, or they can interact differently depending on the brewing method. Roasters carefully monitor bean temperature, airflow, and roast time. But even with precision, small daily differences in ambient humidity, bean moisture content, or equipment calibration can cause variations in flavor. Roasting is not just about chemistry, it's an art. Roasters make adjustments based on smell, color, and even sound, listening for the first crack and second crack in the beans. These auditory cues correspond to structural changes inside the beans and are key indicators of flavor development. The same beans roasted differently on different days can taste surprisingly distinct, even if all other variables remain constant. Understanding the chemistry behind roasting helps you appreciate why coffee is never the same. It's a living product, influenced by heat, time, and chemical reactions that are incredibly sensitive to small changes. When you notice a difference in taste, it's not a mistake, it's chemistry expressing itself. Each cup becomes a unique experience, shaped by thousands of chemical interactions happening in a tiny roasted bean. Even after roasting, coffee continues to change. Beans are alive in a chemical sense. They slowly release carbon dioxide and undergo oxidation, processes that subtly alter flavor over time. This is why a bag of coffee can taste dramatically different if brewed on day one versus a week later. Freshly roasted coffee is rich with volatile compounds that give aroma, sweetness, and complexity. Over time, exposure to oxygen causes some of these compounds to break down. Aromatic molecules degrade, oils oxidize, and acidity can shift, leading to flavors that might seem flat, stale, or slightly sour. Storage conditions play a significant role in how quickly this happens. Light, heat, and moisture accelerate chemical degradation, while airtight, opaque containers slow it down. Even small differences in ambient humidity or temperature in your kitchen can change how fast your coffee ages. This means that 2 cups from the same bag, brewed on different days, can taste different without any change in preparation. The release of carbon dioxide from freshly roasted beans also affects brewing. Covels can create bubbles and foam during brewing, particularly in espresso, but it also affects extraction. Beans that are too fresh may cause uneven extraction due to trapped gas, producing sharper or more acidic flavors, while slightly older beans often brew more evenly, yielding a smoother taste. This explains why some baristas recommend letting beans rest for a few days after roasting. Oxidation also interacts with the oils in coffee. These oils are responsible for aroma, body, and flavor richness. As they oxidize, they can produce stale or rancid notes. Understanding this process gives you insight into why coffee can taste different, even if everything else, beans, water, grind size, and brewing method, is consistent. Each day your coffee is interacting with air, changing at a molecular level, and that's why no two cups are ever the same. Finally, even storing coffee in the fridge or freezer introduces minor changes in moisture and chemical composition. Temperature fluctuations can accelerate oxidation or condensation, subtly influencing flavor. These processes are all natural and chemical in origin, demonstrating that coffee is not static. Recognizing this variability helps you approach each cup with curiosity rather than frustration. It's science, not error, creating unique tasting experiences every day. The way coffee beans are ground has a profound effect on the flavor you extract. When beans are ground, you increase the surface area exposed to water, which allows chemical compounds to dissolve during brewing. However, the size of the grind affects the extraction rate. Coarse grinds extract slowly, producing a lighter cup, while fine grinds extract quickly and can lead to bitterness. Even using the same grinder, minor daily differences, like slight changes in humidity, burr alignment, or pressure, can produce subtle variations in particle size, changing how flavors are extracted. For example, if the grind is slightly coarser than usual, water passes through too quickly, leaving some soluble compounds behind and resulting in a weaker or less balanced cup. If it's slightly finer, water may over-extract, pulling out bitter compounds and masking subtle notes. This is one of the reasons coffee tastes different every day. Your grinder, like the beans, is sensitive to environmental factors. High humidity can make the beans slightly stickier, causing clumping and uneven grind sizes. Burrs wear down over time, changing the consistency of the grind fractionally. Even these small shifts affect chemical extraction. Grinding also affects aroma. The finer the particles, the more volatile compounds are released, influencing both smell and taste perception. This is why freshly ground coffee often smells more vibrant, but the exact intensity can fluctuate daily depending on bean freshness and environmental conditions. Some professional baristas weigh the coffee meticulously and adjust the grind daily to account for these variations, highlighting how sensitive the chemistry is to tiny changes. Understanding grinding as a chemical and physical process gives coffee drinkers insight into daily flavor changes. Even with the same beans, brewed the same way, a slightly different grind can result in noticeable differences in taste, mouthfeel, and aroma. It's a reminder that coffee is a living beverage interacting dynamically with every step in the preparation process. Appreciating these subtleties turns each cup into a mini experiment where small adjustments and daily variables reveal the fascinating complexity of chemistry in action. Water is more than a medium for dissolving coffee. It actively shapes its flavor. Coffee is roughly 99% water, so its chemical properties influence the extraction of flavor compounds. Minerals like calcium, magnesium, and bicarbonate affect how acids and sugars dissolve. Water pH also plays a role. Slightly acidic or alkaline water can accentuate or mute certain flavor notes. That's why a coffee brewed with the same beans and grind in New York can taste different from one brewed in Los Angeles. Calcium and magnesium, collectively called hardness, help extract flavor compounds more efficiently. Hard water can bring out richer body and balanced acidity, while very soft water can produce a flatter taste. Alkalinity interacts with acids in coffee, affecting perceived sourness. Even trace elements like sodium or potassium subtly influence mouthfeel and aroma. These effects are minor, but coffee is a subtle, nuanced beverage, and small chemical shifts are detectable to our taste buds. Daily fluctuations in tap water composition, seasonal changes, and even the plumbing system can alter extraction. That means your favorite brew may vary day to day, even if all other variables, beans, grind, brewing method, are consistent. Professional coffee shops often use filtered water with controlled mineral content to standardize flavor, but at home, small differences are inevitable. Understanding this reveals why coffee is never static. The water itself is an active participant in the chemical process of brewing. Additionally, water temperature affects extraction efficiency. Hotter water extracts compounds faster, which can intensify bitterness or acidity. Slight variations in kettle temperature or ambient conditions on different days can change the cup's balance. The combination of mineral content, pH, and temperature means that water chemistry alone can explain noticeable daily differences in flavor. Appreciating this chemical interplay deepens your understanding of why coffee is as much a science experiment as a comforting daily ritual. Brewing coffee is where all the previous variables, bean chemistry, roast, grind, water composition, come together. It's the final stage where chemistry becomes taste in your cup. Even small differences in temperature, brew time, or pouring technique can change which flavor compounds are extracted and therefore how your coffee tastes. This is why the same beans can produce subtly or dramatically different cups on different days. Water temperature is a key factor. Ideal brewing temperatures are generally between 195 205 degrees Fahrenheit, 96 degrees Celsius. If water is slightly cooler, extraction slows, leaving some soluble compounds behind and creating a weaker or underdeveloped cup. If it's hotter, extraction accelerates, pulling out more bitter compounds and masking subtle sweetness or acidity. Even a slight deviation of a few degrees, which can happen with different kettles or environmental conditions, changes the chemical balance of your brew. Brew time is another critical variable. Longer contact between water and coffee grounds allows more compounds to dissolve, but it also increases the likelihood of over-extraction, which produces bitterness. Shorter brew times may under-extract, resulting in sourness or thinness. That's why a French press brewed for 4 minutes tastes different from one brewed for 5 minutes, even with the same beans and grind size. Even small daily fluctuations in timing, intentional or accidental, shift the chemistry of extraction and therefore the flavor. Pouring technique matters too, especially with methods like pour-over. The rate and pattern of pouring influence how water interacts with a coffee bed. Pouring too quickly can create channels where water flows unevenly, under-extracting some grounds and over-extracting others. Pouring more slowly allows more uniform extraction, highlighting balanced flavors. Even a slightly different pour pattern, which might happen naturally on a rushed morning versus a relaxed morning, can change the cup. Pressure is particularly important for espresso. The way water is forced through tightly packed grounds extracts flavor quickly. Variations in tamping pressure, grind consistency, and machine calibration affect how much of the bean's chemical compounds end up in the cup. The result is why espresso shots pulled at the same coffee shop can taste subtly different throughout the day. The takeaway here is that brewing isn't just a mechanical step, it's a chemistry experiment in miniature. Every parameter interacts with the coffee's chemical composition, and small, daily variations are inevitable. This explains why even meticulous home baristas, following the same routine every day, notice differences in flavor. Embracing this variability lets you explore coffee as a living, dynamic beverage rather than expecting exact replication. Even with perfectly consistent beans, water, and brewing, your perception of coffee can change from day to day. Taste is not only chemistry, it's neuroscience. Your mood, level of fatigue, environment, and even recent meals influence how you perceive flavors. Bitter compounds taste more pronounced when you're tired, while sweetness and aroma are enhanced when you're alert and relaxed. This is why the same cup of coffee can seem brighter and sweeter in the morning, but more bitter or muted in the afternoon. Smell is closely tied to taste. Coffee aroma compounds are volatile and highly sensitive to temperature and humidity. On a humid day, aromatic molecules may evaporate differently, changing how your brain perceives flavor. On a dry day, your cup may seem more intense. Even your environment, lighting, sounds, and visual cues can influence your taste perception. Studies show that flavor is a multisensory experience, and our brains integrate sight, smell, and texture with chemical taste signals. Psychological factors matter too. Anticipation, expectation, and habit affect how we experience flavor. If you're particularly looking forward to coffee after a long morning, your perception may emphasize sweetness and balance. If you're stressed or distracted, bitterness or acidity may dominate. Fatigue reduces sensitivity to some taste receptors, subtly changing how flavor compounds register. Other variables include diet and hydration. Eating something salty or sweet before your cup can affect your perception of acidity or bitterness. Hydration level influences taste receptor sensitivity, which is why coffee can taste different if you've had water versus if you're dehydrated. Even minor fluctuations in sensory perception highlight how dynamic coffee tasting is and why no two cups are ever identical. Recognizing the role of perception allows you to approach coffee with curiosity. Differences in taste are not always a product of brewing mistakes. They reflect a complex interplay between chemistry and human physiology. Your daily cup becomes a reflection of both the coffee's chemical makeup and your own sensory state, making each experience uniquely personal and scientifically fascinating. So why does your coffee taste different every day? By now it's clear that multiple layers of chemistry, biology, and environment are at play. From the origin of the beans to seasonal variations, genetic differences, roasting chemistry, freshness, grinding, water chemistry, brewing technique, and even your mood, each cup is a unique chemical experiment. Rather than viewing variability as a flaw, it's an opportunity to appreciate the complexity and beauty of coffee. Embracing these differences can transform your coffee routine. Instead of seeking identical results every day, you can approach each cup with curiosity. How does today's cup compare to yesterday's? What flavors are more prominent and why? What brewing adjustments could highlight different notes? This mindset shifts coffee drinking from a mundane habit to a daily exploration of chemistry and sensory experience. The variability also reminds us that coffee is a living product shaped by natural forces, human cultivation, and countless chemical interactions. Beans respond to the environment, roast reacts to subtle changes in temperature, extraction depends on water composition and brewing method, and perception is influenced by our physiology and psychology. Each cup is a snapshot of this dynamic system. Practically, you can explore this complexity by experimenting with small variables. Adjust grind size, water temperature, or brew time. Note how aroma, acidity, body, and sweetness change. Even small tweaks can teach you about the delicate chemical balance in coffee. Over time, You begin to understand your personal preferences, develop a deeper appreciation for the science behind your cup, and cultivate the skill to highlight flavors you enjoy most. Ultimately, coffee's variability is part of its charm. It teaches patience, observation, and awareness of subtle chemical interactions. Each cup is a little experiment, a moment to engage with science in a way that's tangible, delicious, and personal. So the next time your coffee tastes different, remember it's not a mistake. It's chemistry, environment, and perception, all working together to give you a new, unique experience every day. Appreciating that complexity makes coffee drinking richer, more mindful, and endlessly fascinating. So, what can we take away from all this? Your coffee tastes different every day. Not because you made a mistake, not because your beans are bad, and certainly not because the universe is conspiring against your morning ritual. Each cup is the result of a fascinating dance between nature, chemistry, and even your own senses. From the soil and weather that shape the beans, to the genetic quirks of the plants, to the subtle differences in roasting, grinding, and water chemistry, every step adds its own influence. Even your mood, your taste buds, and the ambient environment contribute to the experience. That means each sip is unique, a small chemical symphony performed just for you on that particular day. Instead of feeling frustrated when your coffee tastes different, embrace the variability. Think of it as a tiny science experiment you get to taste with every cup. Adjust your grind, try different brewing techniques, notice how water changes flavor, and pay attention to what your body perceives. Over time, you'll start noticing patterns and learning what factors highlight flavors you love most. The variability is not a flaw, it's a feature of coffee that makes it endlessly fascinating and endlessly enjoyable. So, the next time your cup surprises you, whether it's brighter, fruitier, more bitter, or richer than yesterday, take a moment to appreciate it. You're tasting the intricate results of chemistry in action, reactions in the bean, interactions in the water, extractions influenced by heat, and molecules engaging with your senses. That's science you can smell, taste, and savor. Every cup is a reminder that even something as simple as a morning coffee is alive with chemical complexity waiting to be explored and enjoyed. In the end, coffee is more than a beverage. It's a daily celebration of chemistry, a living experiment, and a delicious invitation to be curious. So sip, savor, and let science delight your taste buds, one unique cup at a time.